Yeah. Hello there, and welcome to this tutorial for fine-tuning Gemma model to reason using Tunix, a new library by Google. So for this tutorial, I'm going to talk about the problem that we're trying to solve in this tutorial. So firstly, the problem is that most LLMs do not show their reasoning traces. So we're trying to show the reasoning traces by using reinforcement learning through GRPO, which is group relative optimization, a principle of fine-tuning LLMs. So here are some of the libraries that we are going to use. We're going to use JAX because it's a fast and high performance library, and we're going to use Flask to create our neural network and to initialize QLoRa because we're trying to utilize as much compute as possible on the V5E 8 TPU processor. Then after this, the second step is importing the given hyperparameters such as temperature, K-map, so that we can use these hyperparameters to train our new model. Then from here, we are going to preprocess the data that is going to be used in the project so that it can have reasoning tokens. We are using the dataset from which is G8MK from OpenAI. It's a math related kind of data set so that we can extract the values from the given output from the models and use reinforcement learning in order to reinforce the outputs of giving those reasoning traces. So here, in this tutorial, we are using reinforcement learning so that every time the model spits out the given reasoning traces, the model is rewarded so that it can keep on producing the same outputs over and over again. So in that sense, the model is going to be reinforced to generate the same given output. So this here is showing the scores and the scores given and penalties given if the model produces the output tokens and if it fails. And every time it fails, meaning the model's weights and biases are not going to be saved. It's going to mostly prioritize the weights and biases for the reasoning task. So the more it reasons and produces those output tokens, the more the system is reinforced. So the next step is splitting the data set into training and testing sets, and then we save them as CSV files, and then we initialize the trainer so that we can train the model. Then we evaluate and check how the model is outputting its results, as you can see on the screen. And from here, we can now save the checkpoints so that we can reload the model and keep on reusing the model for other use cases and to keep on and to evaluate it more and stuff like that. So thanks.